Hello, sir. Voice is not audible.
Hello.
Yes, sir. Hello. Good afternoon, sir.
Hello. Good afternoon to all. I am Sudhakar, one of the teaching assistants for this course. Due to some urgent work, Professor Shankar Ram is unavailable today. So I myself, one of the teaching assistant, and Mr. Suresh, also a teaching assistant, with along with Mr. Shravan, is a senior research college Department of Engineering Design, are going to take this session. Please ask your doubts. Thank you.
Sir, in week one, how to if the question main effective pressure as well, and then how can we solve, sir? If I forget the formula, then how can I proceed? Main effective pressure equal to what done by swept volume. Then we can solve or anything. Because long expression are there, sir. For auto dual and diesel, difficult to memorize.
No, we are unable to get your question. Can you come again?
Sir, I start from week one, sir. Doubts. Then, sir, in week one, at the end, sir discussed about mean effective pressure for the calculation of mean effective pressure. If I forget in mean effective pressure because the expression is too much long as compared to efficiency formula. If I forget, then how can solve conceptually? or auto dual integer?
Yeah, the equation is very long, but it'll see either you can remember it or you can derive it, but derivation also will take a long time to do. So you're asking how is there any alternative way to get mean
Yes, sir.
effective pressure, right?
Because that
Uh,
much difficult than dual cycle efficiency, that expression.
yeah.
Even for auto
They are
cycles.
very lengthy, but typically you are not expected to remember it apart from exams and all, right? So I think it is fine. But yeah, I don't think there is any shortcut or something to uh, get the mean effective pressure apart from using all those P naught, V naught, gamma, cutoff ratio, and all that.
Okay, sir.
Can you please, hello sir,
Yeah.
can you please tell some tips or guidelines for exam?
Guidelines. There is no specific guidelines for this, sir. The questions will be asked whatever we taught in the class, professor taught in the classroom during the classes. So the questions will be very straightforward. So if you go through whatever you have studied in this particular course, it will be fine, sir. There is no need of to cover any other books for this particular examination.
And moreover,
Okay,
you can
sir.
go through your assignments also. The assignments also will be helpful for attending the exams.
Sir, from assignment, how many questions will come direct?
So there is no specific benchmark for that. So that you can take as a reference, the assignments as a reference. So it could help you. Dealing assignments in full-fledged will definitely help you to solve the end semester problems at
Yes,
least.
sir. Assignments are easy and direct, straightforward. But if I appear exam and exam is little twist, then how can I manage?
See, at the end of the day, whatever sir covers in class will only be coming for the exam. And from the assignments, you will get an idea of how the questions can come for the exam, right? It can be of similar pattern. That's all I can say. If I tell too much, I guess it will be unfair and you'll be revealing too much information. But yeah, basically the template will be the same as how you get your assignment questions.
For numerical, what can we expect? Any for this course?
Yeah. So numericals also will be of the same flavor as that in the assignments, and also like whatever problems or formulae sir discusses in class, you can expect such kind of numericals to come for the exam.
Based on
And,
final expression.
sorry,
Based on final expression. Not from that.
that I cannot reveal because it can be anything, right? It can be any
Mr.
intermediate step
Adarsh,
also.
Mr. Adarsh, actually say the thing is
Yes,
the
sir.
course is well balanced by if you watch the video properly, if you attend the if you study the assignments properly, it will be easy to attend the exams very easily. Okay, so there is no we cannot reveal beyond this level. Okay, so this is the maximum level which we can reveal.
Yes, sir. Okay.
Okay.
How to do it?
Sir, please solve the numerical which came in week 7. Transmission, gear transmission.
So what's your doubt exactly?
Numerical based on gear transmission, gradability there in numerical week 7. Please solve that.
Week 7. Okay, week 7.
Assignment question.
Assignment question, no?
Yeah,
You have access to.
yeah.
Okay, give us a minute.
Yes, asking me
So,
what is
what exactly in the assignment question do you want to know? Hello?
Week 8, right? 7.
Week 7. Sir.
Week 7.
Hello. Yes, sir. From
Ah.
7 to 11.
Good. Okay.
That is the thought
Yeah.
what I read before. Because sir did not solve any questions, so we are stopped, sir.
Okay.
Hello, sir. Hello.
Yeah.
Hey, my name is Sri Harigovind. So, I also have a similar doubt regarding the question number 7, which is actually mentioned by Adarsh. So, in that, according to the video, he was actually given the ratio for the gear ratio equation. But thing is, like for successive gear ratio, final drive, and value of first gear ratio, he didn't mention in that video which he shared.
But so the relation between the gear ratio, you are supposed to take it as a GP, right? The transmission
It's
ratio.
actually GP ratio, sir. Actually, the one which he given is the GP ratio. But
Okay.
when we actually came across the different materials, the equation is kind of varying, sir. Like it's not based on what he given.
Yes, sir.
Um,
They twisted.
Oh, it's twisted.
Yes, sir.
What exactly you want to know, sir?
Solution.
So
Solution how to
No. Solution of what? It's a live interaction session. You just ask. It will be good if you ask precise questions. So, in which area you have exactly doubt?
Sir, actually, to find out the proper equation, sir, like regarding
Sir,
if any kind of questions be asked for this gear ratio, like how we can able to determine all those kind of parameters which is mentioned, like successive gear ratio and all.
yeah. So sir has solved an example problem in class, right?
Uh,
Where
no, sir.
the
Not solved.
no, sir,
maximum
for
torque. Yeah.
Sir, not solved.
he didn't
Sir?
solve any problem for this, sir.
No. The general equation for the maximum vehicle longitudinal speed is given, right? Radius of the wheel, omega max, and 1 minus lambda.
Sir, that's actually the gear shifted, and when it is from I-1 to ith position, sir. Like the doubt is
And that
actually
is only
regarding.
for finding the gear ratios.
Oh,
Okay. First you should equate a V max equal to
yes,
radius
sir.
of the wheel, omega max, into 1 minus lambda whole divided by whatever the speed, top speed. Suppose it's a 4-speed gearbox, it's NT4. Then the gear ratio of differential. If
Okay, sir.
you in that you first find a differential gear ratio, first. Okay. If you once you find the differential ratio,
Yes, sir. In that
See, for a-
NT4 is we can able to consider it as one, right? So because it will be in the straight gear drive, like
no,
when it is
where
in fourth gear.
ND means differential.
Hi, sir.
No,
But
differential in
according.
automotive. No, sir. Please wait. In differential, in automobile, there is no 1:1. It is
Oh.
for a heavy commercial vehicle, it would be 6:1. For the light commercial vehicle, it should be around 3 to 4:1.
Okay, sir.
The differential always has the reduction gear ratio.
Okay.
But in the question, the fourth gear is given to be direct drive, right?
Direct drive, sir. That's what.
Right. So that is another information which is given, right? So using that and your what do you say, the demanded traction, maximum traction, using those two equations, you'll have to get the in between gear ratios, right? Which and also another relation you have is the GP relation, right? So I think you have enough number of equations and enough number of variables to go ahead with it. So maybe I can say you can get all the gear ratios in terms of the direct drive and the variable kg, and then substitute that in the rest of the equations, and I think it will take care of itself then after that.
In the place of NT4, you should put 1, sir. Since it's a gearbox is 4-speed gearbox and the fourth is a top gear. So in the place of NT4 in the equation, you can substitute 1. By the way, you can find the differential ratio. Once you find the differential ratio, you can subsequently use the Tmax equation.
Sir, and also one more question. Like in this, like they actually mentioned gear ratio subsequent gears, right? So in that subsequent gears, in the refers like 1 to 4 or 1 to 2.
Subsequent means 1, 2, 3, 4, sir.
Oh, so ratio of 2, like in that, the question specifies ratio of 2 successive gear ratio, right, sir?
No, can you come back, sir?
The question says that ratio 2 successive gear ratio. Is it
That's what
refers to,
GP. They're asking GP, sir.
oh, GP of 1 to 4, like 1, 2, 3,
No,
4
no,
into that.
No. The ratio. So successive. So in this gear problem, NT2 by NT1 is equal to NT3 by NT2 and so on, right? So
Yes,
that
sir.
ratio they're asking, kg.
That is constant for all the successive gears. If you,
Okay, sir.
yes, kg,
Okay.
not k. We use kg here.
Yeah.
It's a kg, that constant which is
kg.
being mentioned.
Yes,
Right, sir.
kg is doesn't change for every ratio. It is a fixed ratio. By geometry
Okay,
progression,
sir.
we find it.
Yes, sir. And also, like in that, if we actually calculated, then what gear ratio, I mean, what to what we need to actually consider? Like, is it for first to third gear or first to fourth gear? I mean,
So
we,
they're asking for successive, right?
yes,
So
sir.
successive means from one to the next.
For 1
Right.
to
So
2.
yeah, you can assume that.
Okay, sir.
Yeah.
Thank you, sir.
So the idea is you first find by equation, you would find NT1. Some ratio will be coming by substituting the values in the appropriate equation. You would find 1. Then you multiply with the kg. Then you would end up with NT2. Again, if you multiply kg, then you would end up with NT3. It goes there on.
Oh, okay, sir.
The ratio remains constant for successive gears. First, you need to find NT1. What is the ratio for first gear? Then you subsequently you should keep multiplying.
Sure, sir.
Sir, in airbag system, both primary and secondary circuit are little confusing, sir.
Sorry, sir.
In airbag system, primary and
Yes.
secondary circuits,
a
little confusing.
Have you watched the video we have released in the YouTube?
Yes, sir. Yes.
So the ideally the primary circuit will take care of operating the rear axles, and the secondary circuit will take care of operating the front axle brakes.
Front regulated by quick release valve.
Sorry, sir.
Front regulated by quick release valve.
No, not quick release valve. It is regulated by handbrake. Brake valve or the treadle valve. One that operates by the driver.
Front wheel.
No, sir. There will be a common brake valve that is operated by the driver. We have two. We would have give two inputs to the compressed air input source differently, independently to the brake valve. As the driver presses the brake valve, the two independent sources will go independently to both front and rear axles. Actuates rear and front and rear axles independently.
Yes, sir.
Even one line got ruptured or one line malfunctioning, the other will make sure the stopping the vehicle.
Yes, sir. Sir, related to friction ellipse, if if wet road surface area means it squeezes or expands, sir?
It contracts basically.
Contract.
Yeah.
What is the mechanism behind, sir?
So typically, in a high friction surface, you would get more traction force, right? Because of by nature, I'd say. When the coefficient of friction decreases, basically the surface is more slippery, right? So you would get less traction force, right? So the friction ellipse basically tells you how much relative traction force is available in the longitudinal direction as well as the lateral direction. Right. So if the friction force, when you go down from a high friction surface to a low friction surface, friction force decreases, right? The same thing is captured by the friction ellipse.
Hmm.
Okay, size of the friction ellipse basically tells you how much traction force is available on the surface.
Oh, yes, sir.
Okay, so typically when you go from high friction to low surface, the amount of traction force decreases, right?
Hmm.
So same thing is conveyed by the friction ellipse.
Yes. And in between, sir told like a resultant. What is
Sorry?
resultant?
Resultant.
Okay, yeah. So right. So if you're say you're traveling in a straight line, okay,
Hmm.
and you press your brakes.
Uh,
Now all the traction force will go into stopping your vehicle, right? Which is in the X direction because
Hmm.
there is no lateral
Longitudinal.
motion. It's just straight line
Yes, sir.
braking.
Hmm.
Now assume you're taking a turn and you're braking. Okay. So in that case, there will be some force acting in the FY direction,
Lateral.
which helps you in taking the turn,
Hmm.
and another force which is helping you in slowing down. That is the FX. Now the resultant force will be, combination of this FX and FY, and it will be on this ellipse. Okay.
Yes,
So
sir.
in this case, there is both FX and FY.
Uh,
Okay. So the
when
max, yeah.
when sir completely lateral direction.
So if you're just taking a turn without slowing the vehicle down, then
Skid.
there'll be a pure FY force acting on the vehicle. So yeah,
Sir
that time,
also told that skid will happen.
sorry.
Skid.
Yeah.
Yeah. So if you exceed your demanded friction force,
Hmm.
you'll end up skidding, right? If my demanded lateral force is beyond that which is provided by the surface.
Beyond the
That,
ellipse.
yeah, so it's basically outside the friction ellipse.
Hmm.
Then
Then
your vehicle will start skidding because your surface cannot sustain that, cannot provide you the required, traction force.
Hmm.
In such cases, the demanded Fy will be outside your friction ellipse.
Yes, sir. Regarding sir, brake power and time relations, and three modes: open mode, hold mode, and release mode.
Sorry, I didn't
Car.
get you.
Open hold release.
Sir, regarding sir, brake power, brake pressure versus time car. How to represent the open mode, hold mode, and release mode?
How to represent
Open
apply,
mode,
hold, exhaust?
release, hold, open.
What do you want to know? So that is basically the phases of the air brake system, right?
Anti-lock.
Yeah, okay. So typically, when the driver applies the brakes, you go into apply mode. So the compressed air from the compressor
Hello.
starts filling your brake chamber, which in turn applies the brakes on which actuates the brakes on your S-cam brake set.
Sir, your voice is
Right.
not audible.
Is it better now? Hello? Hello? Hello, am I audible? S-cam brake set.
Sir, your voice is
Right.
not audible.
No, it's okay for us actually. We don't know what happened.
Okay. So it is audible.
Yeah, you are audible, but it is
Huh.
okay for us. I don't know what is about this Mr. Adarsh.
Adarsh, can you hear me? Is Adarsh?
Yes, sir.
I think Adarsh. Okay, yeah. Can you hear me?
Yes, sir. Now audible.
Yeah. So what I was saying was, when the driver applies the brakes,
Hmm.
okay, initially, you start filling the brake chamber, okay, and thereby actuating the S-cam brake setup. Now, the ECU of the vehicle realizes that your wheels are going to lock because you're on a low friction surface. That's when the ABS gets triggered. Okay. So when your wheels are going to lock, what happens is the ECU tells the this what is this the regulators, pressure regulators, to release the brake pressure, so that the vehicle so that the wheels can start moving again. Why? Because wheel lock is potentially fatal. Okay. Rear wheel locks can cause vehicle instability,
Instability,
and
front wheel direction.
yeah, you lose steerability.
Stability, steerability,
So
direction.
exactly. So to avoid this wheel lock, you release the brake chamber pressure so that the wheels can start spinning again. Okay. But you at the end of the day, what you want to brake your vehicle, right? You want to stop your vehicle. So you apply your brakes again. So you do this to make sure you are operating on the optimum slip region. Okay. So
20%.
Sorry?
20%.
Yeah, which is I mean, it's not 20% is
Hello? Sir, not
yeah.
audible.
Yeah. Sorry. So
Hello? Sir, your mic is off.
someone is muting me, I think.
It's me.
Okay. Yeah, what was I saying? Yeah, 20%. So 20% is not the case in all conditions, because the optimum region of slip mainly depends on the wheel slip curve, which depends on your loading condition, the road on which you're traveling on, your tire pressure, and various other factors. So first thing, the vehicle has to figure out what surface you're operating on. Once you figure that out, you basically apply an exhaust based on where you are operating, based on your current operating state. So suppose if the wheels are about to lock, I go into exhaust mode, and suppose it is suppose I am within the safe region of the wheel slip curve, I apply so that I can operate in the optimum slip region. So that's what. So this apply hold exhaust cycle is realized using these pneumatic pressure regulators. Okay.
Sir, how this periodically curve open, hold, and release is viewed from V and R omega?
Could you repeat?
This open, hold, and release modes, how viewed from V and R omega?
Yeah. So V and R omega is used to compute slip, right?
V decreases and R omega periodical decreases.
Right. So at the end of the day, you want your V to decrease as fast as possible, right? Because that's what you want when you brake. Correct?
Linearly.
Linearly, it may not be the case. That ideally, yeah, we want as high deceleration as possible. But in reality, that may not be the case, right? Because you're doing all these apply, hold, exhaust cycles.
Okay, ideally,
Yeah, ideally, you want it to you want your vehicle to decelerate at the maximum possible deceleration, but uh, that may not always be the case, right? Because
Yes, sir.
your surface is not always uniform, and braking also might not be uniform,
Perfect.
right? So it need not be always uniform, basically.
Okay. Then, sir, R omega, how to reduce? Here,
R
R omega
omega
cyclically
reduces,
reduce.
right? So R omega reduces by increasing the brake torque, right? When there is brake torque, your omega decreases, right? Omega of the wheel, because that is acting against your wheel rotation.
Power equal torque and omega. Torque increases, omega decreases.
Oh, no. That's in the traction case. We are talking about braking here, right? Yeah. So in braking, the braking torque acts against the direction of rotation of the wheel. Right?
Clockwise and anti-clockwise are told.
Right. Yeah. So if your wheels are rotating in the clockwise direction, brake torque is applied in the anti-clockwise direction, thereby
Yes, sir.
reducing your omega. Okay.
Yes, sir.
Yeah.
Hello.
Yeah.
Yes, sir. Here, in horizontal direction, x-axis fx is function of coefficient of friction and wheel shift ratio, or longitudinal wheel shift, alpha tire slip angle, and camber angle. What is the slip angle and camber angle?
Slip angle and camber angle will be, will govern your lateral force, not your longitudinal force. Of course, they are both, constrained by the friction ellipse,
Hmm.
but your longitudinal force is basically a function of mu, as you said, and mu is a function of your wheel slip, longitudinal wheel slip.
Longitudinal is a function of lambda, wheel slip
Yeah,
ratio.
correct, lambda.
Okay.
So basically, mu varies depending on your wheel slip, which is again, what do you say? It depends on various conditions like your tire pressure, type of tire, your surface, and
Yes, sir.
all the external parameters.
Then, sir, how friction related to velocity?
How friction is related to velocity?
Hmm.
So okay, that's a very broad question. So
Directly affects omega.
there are two possibilities here. One is your friction during braking, right? So their friction force slows your vehicle down,
Hmm.
correct?
Hmm.
And another case is during traction. So in that case, you are being pushed forward by the road, correct?
Yes, sir.
So there, it's a very broad question. Basically, it does both, propelling your vehicle forward as well as helping your vehicle stop.
Hmm.
Again, more details I think will go into tire mechanics and all that, which is part of the vehicle dynamics course.
Okay, sir.
Yeah. Anyone else have any questions?
Sir, always friction inverse relation with the temperature.
Yeah, temperature is also a big factor. Yes.
Inverse.
Sorry?
Inverse relation.
Inverse. That is very difficult to judge because it's
Because
outside our scope, right?
in brake side, sir told reduction in the brake friction lining coefficient with the increase in temperature.
Oh, you're talking about the temperature of the brake lining.
Coefficient. Yes,
Ah.
yes. As the temperature increases, the coefficient comes down. As the temperature of the brake shoe increases, the coefficient of friction comes down.
I got tired.
This rule apply anywhere, sir.
Is this concept applied everywhere?
Yes. Meaning? What is the exact meaning? What is the exact doubt? in this?
Sir, always system is inverse relation with temperature.
Your voice is a bit muffled.
Sir,
Can you repeat?
nowadays is always system constant is inverse relation with the temperature. Like here, breaker
That
condition
depends on the
inverse.
material.
So in general, brake shoes, if you exceed the if you increase the temperature, obviously the friction, the coefficient of friction will come down.
Yes, sir.
Yes.
Only the friction comes from
Yes, yes. That don't prefer drum brakes in the.
In front, front. Look. Sir.
Yeah.
In cars, always use hydraulic brake or air brake also can use it.
In cars,
Yeah. In
can
cars,
we use air brakes or not?
yeah, we can use both. But the problem is the air brake system requires the compressor reservoirs to be fixed in the car, but where the space is very
Bulky.
limited. So that's why we prefer the hydraulic brake system.
Hydraulic brake.
Yes.
In racing cars, sir, what type of their?
Racing cars.
Yeah, hydraulic brakes only. You know. Okay, with this, we conclude this session. If you have any doubts, you can come to forum and ask.